Domain and range. When looking at the domain and range of a graph, we first have to remind ourselves what the domain and range are. The domain, when we defined it earlier, is a set of first elements in a relation. When we're talking about a graph, it actually means the possible x values for our graph. The range is a set of second elements in a relation, or on a graph, it would be the possible y values. So let's first consider the graph of the parabola below. So we're trying to look for what x values are possible here in this graph. In this case, any x value would work because we can see here that because this has an arrow on the ends of this parabola, these lines or these curves extend out forever and ever. So all x values would be accounted for. So if we were going to describe this in words for the domain, we would say all values are possible. Okay, we can go further then and express this on a number line. So if I was going to draw just a simple number line, and I'll put a few values on that number line. Just go. Okay. If I was going to shade or highlight the areas of this number line that will be represented as a domain, I can actually shade everything. And I would have to indicate through my shading that that will continue forever. So there it is on a number line. Using interval notation, then we would take it further and say that the graph goes forever in the negative direction and forever in the positive direction. So in interval notation, we would say the graph extends from negative infinity to infinity, using rounded brackets, because with rounded brackets, it indicates that we never actually reach that point, and you can never reach infinity or negative infinity. And then to write it in set notation, we would say that the x values that are possible are all real numbers. So we've expressed the domain of this graph 4 different ways, using words, a number line, the interval notation, and set notation. And we'll do the same thing for the range. So we look at the range of this graph. We look at all values of y that are possible. And we can see here that y actually has a lowest point of negative, looks like -3. And then all values above y would be accounted for. And that goes forever because our curve does, like we said, extend and keep going up forever and ever. So our y values can go from -3 up. So if I was going to write this in words, let me just extend my screen here. Okay, if I was going to write this here in words, we would say for our domain, or sorry, our range, okay, values of y from -3 and up, okay, or values of y -3 and greater. So if we had to put this on a number line then, and you can draw a horizontal or a vertical number line, it doesn't matter. I know that on my number line I do have to have values. At least -3 has to be on there, and I have to go further up than that. It's always a good idea to indicate an arrow here that your number line does extend. So if I was going to shade on this number line now, what values are represented on my graph, I know that it happens at -3, right here, and then it continues on up, and it goes forever and ever. So we have to make sure we indicate that it starts at -3 and goes on up. If I was going to use interval notation for this one, my graph begins at -3 and then goes up forever, so it extends to infinity. And we never actually reach infinity, so we use a rounded bracket. -3 is a definite point that we start at on our graph, so in that case we'd have to use a square end bracket. And then the set notation for that, we have to describe that y is going to be -3 and greater. So it's y such that y is going to be greater than or equal to -3, where y would be an element of the real number system.